to introduce our SVP of Sales, Josh Kurtz, and our VP of Sales, E.W. Doval. Josh?
Thanks, Amanda. Appreciate it. Thank you, everyone, for joining us today. Looking forward to a great webinar. E.W. Doval here is with us today. E.W. has over 15 years of experience in the lighting and energy fields, and he's going to talk to us about LED lighting capabilities for today, tomorrow, and into the future. Thanks, E.W.
Thank you, Josh. Good afternoon, everybody, or for those of you on the West Coast, good morning. Typically, I start off with a slide that when I do a presentation, and it's particularly apropos for this week, but this is something that I firmly believe that the most important people in our country are the men and women that are serving our country now and the men and women that went before them. If you don't believe that, nothing I'm going to say after this slide is going to make any sense to you. These people are responsible for me being able to sit here today, for you being able to sit in your chair, in your office, your house, to listen to me. I thank you, my family thanks you, my company thanks you for your service to our country and one of the greatest nations in the entire world. So I'm going to jump right into this a little bit today. Part of what we're going to talk about today is to give you some objectives. We're going to analyze cost and savings when it comes to LED retrofits. One of the things that comes up typically is that you have people thinking that the cost is too much versus the energy savings. That may have been true 2, 3, 4, 5 years ago. And just to give you some framework, my first LED project was over 14 years ago. We're going to review a case study that shows a little bit about LED retrofits in hospitals, of course, high-performance buildings. But I would like to kind of define high-performance buildings right up front here for you. Your building, when something goes wrong, becomes a high-performance building. So you need to understand all of those things and not just classified under what we typically think is high performance, whether it's a data center or a hospital. Your building also needs to be a high performance building. And the reason why I say that is something changed between yesterday and today in your building, whether it was the temperature outside or the humidity outside or the number of people that were actually in your building. Something changed, and you need to be able to respond to that in your building. And then we're going to talk a little bit further about where we are currently with LED, where we're going to go, and then something that's very exciting from a standpoint of the digital ceiling with LED. All right, now I have technical difficulties. There we go. So just so you understand a little bit of where I come from, I kind of believe that if you can't execute it, it really doesn't count. So here's an example right here of what people say. It's I guess another way of looking at it is walking the walk and talking the talk, rather than talking the talk. This is an example that I had, and some things kind of prick my interest every once in a while. This is actually 2 blocks from the White House. And you know, everybody understands that the word sustainability is out there. People probably may not even understand where it's defined. I'm going to define it for you today very simply. Sustainability is using what we already have, and that's our resources and things like that, and fixing what we already own. Those are our assets. Well, here's an example. I was in a hotel, and the sign there on the left-hand side is a sign that was in every hotel room in there. They spent a bunch of money to put these signs out there that showed, you know, to hang my towels up, and to there was a blue bin for my recycling and things like that. And then I went downstairs to the conference center, and there was a T12 fixture there. This is what I'm talking about, is walking the walk rather than talking the talk. They would have saved more money had they just retrofitted that T12 fixture than they would have purchasing the signs that they had for those individual hotel rooms. So things like that kind of pique my interest every once in a while, and I kind of like to poke the bear every time I can. Here's an example of where we are right now with LED from a lumens per watt. Not just right now, but where we were a couple of years ago. You can see on this chart that we were just over 100 lumens per watt at the chip level. Now I need you to be understand this. When I say the chip level, you have to put that LED chip in a delivery device, a fixture. There are inherent inefficiencies in fixtures, whether it's the lens. Some of you guys have been out there a long time and had T12 fixtures, and you know that they're yellow on the inside. Yellow is not a very good reflective surface. So there's inherent inefficiencies built into a fixture. A typical 2x4 troffer might have 15 to 18% built into the inefficiency of the fixture. A parabolic may have 30%. And why is that important? Well, it's important from the standpoint that it means that you have to put 30% more energy into the ceiling than you would if it was just a bare light bulb, as a for instance. Now, bare light bulb's not conducive to the environment that you work in. I understand that. But that's kind of how simple it is. But understand this. And part of the problem with some of the LED and the stuff that's out there now, and from a marketing standpoint, I can pretty much guarantee you this. If you have a cut sheet that says up to 110 lumens per watt, another way of looking at that is saying you're not going to get 110 lumens per watt. Because again, inherent in the fixtures are inefficiencies. But you can see now that we've advanced a couple years now that we're up in excess of 220 lumens per watt for fixtures. And how we deliver those lumens per watt is very important to how much light we can put on the surface in the areas that you need to use. The other question that often gets asked, of course, is cost. Everybody wants to know cost. I would ask for a show of hands, but it's kind of difficult to see. But I'm sure that everybody out there has unlimited budget right now for electricity and for doing projects, and they also have unlimited amounts of people standing around waiting to do projects. Now, if you're shaking your head, it's obviously not the case for anybody. We all have tighter budgets. We all have to do more with less. What this slide shows you, it's a slide actually that was projected out by DOE, it says that basically by 2020, you're going to be paying the same amount for an LED light bulb as you are for an incandescent bulb. You can see it today, if you think about it. A PAR 38 lamp, 3 years ago, cost $39 at retail. Now you can buy them for $12. So you're seeing that right now at retail. You're also seeing them improving. And one thing that I want to point out to you very, very clearly, every LED product has to have a lighting fax associated with it, kind of like a food label. We have calories and sugar on a food label. With lighting fax, you have the lumen package, and you have the Kelvin temperature that lamp holds. Look at those kinds of things. If you're thinking about buying some LED products for your house, I would suggest if you're married, don't go home with a 4,000K lamp. You'll just turn around and go back with it. Look for something that's more 2,700K. You'll be happier with that. And more importantly, so will your significant other. This is an example of, okay, what does LED mean? Okay, you see on the left-hand side there, that's a 6-lamp T8 fixture with about 220 some watts in it, 135 foot candles. You can see the results. And the interesting thing about this now is that picture on the right-hand side was our first generation retrofit for troffers. First generation. It was 51 watts. Cost a lot of money, but hey, look, it produced the same number of foot candles. Today, we can do that same thing for 38 watts. I don't care who you are, that's plus 80% savings. That's removing 80% of the energy from the ceiling. That's a direct correlation to how much you pay on your electric bill every single month. This is a case study of a hospital in Virginia. We had a 51% decrease in the kWh. We increased the light levels, and sometimes that's what you want to do, sometimes you don't. A couple of ancillary things that you don't typically think about in a retrofit. It's pretty important in a hospital. Probably important in your building also. Now, it may not be that your building has to worry about infection risk, but staying below the ceiling is probably important. It makes the project move faster, you have less disruption to the workspace, and you don't have as much to clean up. I would ask you a question. Is anything good above your ceiling right now? So if we can stay below the ceiling, it costs less, moves faster, and eliminates much of the cleanup. And that's just part of the thing that we don't typically think about. We always think about cost and savings. Those are ancillary benefits to retrofitting. The other thing that it offers is we now have rooms that are dimming capable. The actual install of this ECM went off. We did over 6,000 retrofits in less than 90 days. Here's an example of the actual install itself. It's going to last about 2 minutes here. So that's our LDR retrofit kit. That's the Contour. We now have several different varieties of that. And by the way, all of them have lighting facts. And in fact, if you don't have lighting facts, they can't be DLC on their QLP for DLC, which means they're not eligible for any incentives. All of our products leave this factory with that capability to capture incentives across the nation. You also saw during that retrofit a typical parabolic lens. That went away. So what do you think looks better, that parabolic or this piece here? And again, we stayed below the ceiling, and it took less than 2 minutes to do it. So, many of you, I'm sure, have seen T-LEDs. They're all over the place. I read a report the other day from DOE that there are actually over 190 different manufacturers making T-LEDs. Some of them are really good manufacturers. Some of them you've probably even heard of. One thing you might not have heard of is at least 2 of those very well-known manufacturers in the last 3 years have had recalls, substantial recalls. There have been over 15 across the entire nation since 2013. Why is that happening? Well, I'm going to show you a video a little bit later that'll let you know a little bit about why some of these things are happening. So what do? Part of the problem is okay, do you hook up the black and white on the socket end on one side? Do you hook it up on either side? Do you reuse the ballast? Well, if you reuse the ballast, you still have an existing break point. That ballast is going to fail. So whose fault is it when it does fail? Is it the T-LED manufacturer or is it the ballast manufacturer? You're going to have the 2 of them arguing. I would say this too. No T12 to T8 retrofit that I would have ever done would have not included replacing the sockets. And yet, all of the time we're out there, the sockets themselves are not being replaced by the T-LED guys. Would you ever have done that when you went from T12 to T8? Not in 100 years. The important thing to know, Any of you guys that are out there, you have a socket, okay? And that socket, whether it's a shunted socket or unshunted, oh, you didn't know that they're two different kinds? Yeah, they're two different kinds. One has 2 holes, one has 4 holes. Which one do you have? Well, I'm a lighting guy, and I can't tell you which one you have if I'm on the ceiling. I got to get up in the fixture to figure that out. So let me ask you, beyond that, let me ask you another question. What gauge wire is coming out of the ceiling? 12? 14? What gauge wire goes to that socket? 18? So how do you get 12 gauge wired into an 18 gauge hole? Well, was fortunate enough to sit beside a TLED salesman recently on an airplane, and his comment to me was, oh, it'll fit. So I'm sorry, it'll fit doesn't really fit in the world that I live in. And here's what UL just recently said about this. This is an actual quote, and you'll see it in the notes that we have if you get this presentation afterwards. There's an actual hyperlink that you can connect to. That these installations are being done in several different ways. And what we don't know is how are they being done? Is it creating safety hazards? The TLED that you bought, is it hooked up on both ends? And now you retire and there's a new guy that comes into your building and he goes out and buys one that's hooked up at either end. Well, what happens? Well, the video obviously was I'll find it here in a minute, but I want to talk a little bit about the economics of the TLEDs because, of LED, because typically what you're having is people that don't know what is going on with LED from a cost perspective. I will tell you today that the first cost is a little bit more than traditional lighting. Yes, it is. If you're only focused on first cost, then you're going to be looking more on traditional lighting. I'll also say this to you. I can find no reason at all to have a metal halide fixture anywhere in any building with the exception of one place that I know of, and that's on high mass lighting, whether it's ports or interstates. But other than that, if you're looking at traditional lighting and it includes metal halide, I would suggest that you take a long look at LED. Because here's the thing, LED lasts a long time. Most of it does. What you have to understand is you're not buying a lighting system that's there for 1 year and not. 85% of the cost of a lighting system is the electricity it takes to run that system, not the product, not the labor. The other thing that you need to be careful of is legacy. What do you do when it breaks? I told you a little while ago that 14 years ago I had a project for LED. It failed. Guess what? There was no legacy. I had to replace everything. You know, when everything you're talking about is a solar pole with a solar head on it and a solar panel and a battery box, it gets quite expensive. My point in making all of this is you can recover the first cost of LED lighting now. It's time to go and do it now. So what happens in the future? Here's what I would say. You're going to see costs continue to drop and you're going to see efficiency improve. The question I always get, just how good is it going to get? You know what, I don't know. I'm not a physicist. 3 years ago, the physicists were saying that LED was going to max out somewhere between 235 and 265 lumens per watt. We just had an announcement from a chip manufacturer that, you know, they're going to go past 330 lumens per watt. So I think you're going to see some of those things. It'll wash out. The point is, the economics and the efficiency, the time is now. You're going to see manufacturers that are going to consolidate and change dramatically. What does that mean? Well, what you have is, look at what LED is. LEDs are semiconductors. They're not, it's not lighting. It's not a traditional lighting piece. So who are your semiconductor companies? And you need to find out, that's where this is going to move towards. The guys that are good at making semiconductors are going to be the guys that can make LEDs. You're going to look at where we start to digitize light. Instead of Wi-Fi, you're going to have Li-Fi. And think about that. Every light pole that you drive by on an interstate now is going to have a mini antenna on it that can communicate with your cell phone. Again, I talked a little bit about high-performance buildings and hospitals and things like that, but imagine, we spent 100 years now trying to take the UV out of light. Well, imagine now with how small LED is that we can actually now go in and put UVC back in there. And instead of worrying about washing your hands and putting the stuff, rubbing the stuff in your hands, imagine now as soon as that water comes on the sink that it kills MRSA and Legionella and diseases like that. Because do you know, if you're in the hospital and you get Legionella, it's 80% fatal. What if we could get rid of that just because we put UVC light in the fixture itself and it kills it automatically? We don't have to worry about heating it up. You can't heat it up enough to kill Legionella. It needs to be 140 degrees. Everybody knows you can't wash your hands at 140 degrees. We'll start putting Microban or products like that on fixtures. Again, not only now going to stay below the ceiling and eliminate the dust in your room, but the fixtures themselves will be incapable of actually holding viruses and bacteria. That's a pretty exciting thing for hospitals in particular. Again, we're going to start talking about controls. Every light pole having that. Big Brother's going to know where you are. They're going to know where you are. And the thing is, it's going to be two-way communication. If you're in a Walmart or Lowe's or a Home Depot or any other major retailer that's out there, and you've seen it before where you go on Google and you're searching where you're going to go on vacation, and you want to go to Costa Rica, and the next time that you go back on the internet, all of a sudden you get 5 ads to go to Costa Rica. Well, imagine that you've searched for something on your phone and you're standing there buying motor oil and you get a text that says, hey, we noticed you were looking at this bicycle the other day. We'll give you 20 bucks off if you buy it today from us. That's the two-way communication that's going to be happening, and retailers are going to start taking advantage of that. And it's going to come through the light fixtures. Here's why. What has the most number of units of any system in your building? The most number of units of any system, you have more light fixtures than you have of anything else. So we're going to access those light fixtures and use those for communication devices. There's another product coming out that's called a TM30. The TM30 is going to look at how CRI is calculated with the LED. For the last 100 years, we've calculated CRI a certain way using fluorescent and metal halides and things like that, and that's going to change. The manufacturers are fighting it, but the federal government and some of the educational units are thinking that we need to reassign CRI. Everybody kind of knows who wins there. And then, of course, you have the Internet of Things. Again, some of the things I talked about earlier are going to start to occur. And then the future, power over Ethernet. Imagine this now, that you have a light fixture that is not hooked up to the grid. It's hooked up with the same wire that you have running across your ceiling everywhere right now. Think of this, in your building today, every piece of equipment there that's plugged into the wall, pretty much every piece, has a transformer already on it. It's converting the AC to DC. What if you don't have to do that conversion? What if it comes off of your ceiling in the form of wind power or solar power? It's already DC. And so we just hook it up and run the grid through Cat5 cable. What does that do if you're a new building? How about eliminating the systems, other systems in the building, like security systems, like proximity measures, like heat and humidity, like counting bodies in the building? All of those things in one system are in the light fixture now, and the communication is two-way. Imagine if you're a hospital and you're looking for a piece of equipment, a vital piece, a life-saving piece of equipment. If it's plugged into the wall, now we can track that through the light fixtures. We'll know where that crash cart is. We don't have to go look for it. So imagine the cost savings associated when you can eliminate all of those systems because they're in the light fixture. And the last thing I really want to talk about a little bit is this thing called human-centric control. I'm not convinced completely yet about the human-centric format. You can Google it if you want to and read more about it. But what basically it's saying is, the premise is that 100,000 years ago, the human eye was created to see in sunlight. When we worked, up until the last century, when we worked outside in sunlight. The human eye was created to see in the sunlight. And there's some evidence, it's not completely done yet, there's no, that's the hypothesis. What they're trying to do is restore outdoor lighting to the inside and see what that does to the human body. The initial results, the very, very early results are they've seen that if they can raise the Kelvin temperature up and restore people's circadian rhythm, things like diabetes, cancer, and heart disease, all a host of different human maladies starts to go away. So it's very exciting research. It's very early in it. That there's some things that there might be moving forward could be very exciting from lighting. And the thing to end this up with, guys, I want you to understand, I don't care what you're going to do today. I mean, you probably don't care anything about lighting. I'm a lighting guy. I'm the one that cares about lighting. You have other things to do. But if you start going down the road and start assessing what your building can do, there's certain things that you can do today. My encouragement to you is, you know what? Just start. Go do something today that was different than yesterday. Because then you're going to figure out that you can execute it. The quicker you can execute stuff, the quicker you start saving money, the quicker you start returning value to your company or your agency, which enhances your value to that company or agency. With that, I'm done. If you have any questions, appreciate it.
Thanks, EW. One quick thing I wanted to talk about. I know the video clip would not load, but do you want to explain to the audience what the video showed?
Yeah,
I know you're dying to.
Yeah, it's actually a great video, and you need and we can get it to you, I'm sure. But it's a video where a guy's actually dressed in full arc flash, installing a T-LED into a fixture. He actually followed the exact directions given by the manufacturer. Well, I'll just put it this way: it's quite an explosive event when it happens.
The tube blows up, correct?
It does. And actually, an interesting story about that, I showed it at a conference late last year, and I had a gentleman that was not very happy, obviously, because I was talking about T-LEDs. And he got very angry when I showed that video. And at the point that I finished the video, he stuck his hand in the air and said, "Can you possibly tell me what that video was for?" I was dumbfounded, and so the best I could come up with was, fire is bad? Because fire is pretty much bad across most facilities as far as I know, particularly in facilities that are high-performance building, which again, is your building, a high-performance building.
Excellent.
You bet.
And I think that clip will be in it when we email the presentation out to everybody. So thanks, EW.
You bet.
At this time, the presentation has concluded. Please use the Q&A widget in your console to type any questions that you would like EW or Josh to answer before we wrap up. We have one that came through here. You obviously don't like TLEDs. Do you see opportunities for retrofits across all types of fixtures in the future?
It's an interesting question. I think I don't. There's certainly good T-LED manufacturers out there. I don't have problems with T-LEDs as a group or as a product. I have a problem with, because there's so many manufacturers and because there's so many things out there that are bad, that it's hard to understand what a good T-LED is. If I had to describe one to you, I would say that it's one that's been thoroughly tested. It's one that has the UL both performance and safety labeling on it. And those reports are actually, somebody can reproduce those reports to you. The other thing is I think there's places for them now. Two places I would think of that are common in many buildings are wrap fixtures and vanity fixtures. Those would be two of the places that I think that would be useful. However, I would caution you, make sure that you follow the instructions exactly as the manufacturer states them. There are some very large manufacturers out there that are selling TLEDs, very large, well-known manufacturers. One of them has an instruction sheet to replace a TLED lamp that is 14 pages long. If you miss a step, it's not UL. So don't miss a step, and good luck going through 14 pages of instructions. Does that help with your question?
Yes.
To follow up on that a little bit, EW, we do a lot of projects that Orion's involved in where we do TLEDs. To your point on the wrap fixtures, strip fixtures, for example, as well, we do quite a bit of TLEDs out there.
Thank you, Josh. Someone is asking here, what does TLED stand for from a mechanical engineering standpoint?
Tubular LED. It's a tubular LED. It's no different than the nomenclature that we've used for T8s, as a, for instance, our T12. The T stands for tubular.
Okay. Can you tell me the power factor of your LEDs? We have to pay pretty high kVA charges.
That's a very, very good question. Typically, you'll see power factors that they're referred to as plus 0.9, plus 90%. When you drop below that 0.9%, not only does it impact the kVAR, but it also in many cases impacts the THD. And that may not be an issue from the standpoint of impacting other equipments. I can tell you that it can be an issue with the transformers, which then again does impact your kVAR. So typically our fixtures are going to be above 90%. Many of them are above 0.98. And the other thing that you have to do is keep in mind that those tests for power factor are done typically in a lab with almost perfect power. So you have to be careful as to whether or not where your building is from the standpoint of incoming power. And you know, there's always a plus minus associated with that, but typically you're going to see above 0.9 for any LED fixture that's a good LED fixture.
Someone would like us to talk about the partnership with Cisco and the digital ceiling.
Well, I didn't mention it by name. I was trying to, I would love to talk about it. Cisco with a C. It's a very, very large company. They have the hardware in our buildings. So it's a great partnership for us to be involved with them. They're involved with several different other companies, not just lighting companies, but other ones that have different types of ECMs or energy conservation measures. But we're very excited to be part of that Cisco branding, and it presents, I guess one of the, I've been doing this for over 15 years, and finally lighting is the exciting thing to talk about. It's the cool stuff, and part of that partnership with Cisco allows us to do that. I'm not sure that answers the question. I don't know that I can get too far into the weeds with it because it's pretty exciting stuff.
It is very exciting stuff, and you know, you were talking a little bit about the digital age and the future of LED, and that Cisco relationship falls into that. And certainly anyone that wants more information on that can contact us directly, myself and or EW. But I think I'm get down a rabbit hole here too long with that. So.
Yes, and also if you look in the resources widget, there is a link to the press release that we put out about our partnership with Cisco, which will give you a little more information. Before we get too sidetracked, EW, if you go to the end of the presentation, you could actually run that
Oh.
video you keep talking about.
Okay. It's a real short video, guys.
Here we go.
Again, I would say that fire is just bad for most buildings. So it's, I would think that your building would become a high-performance building if the sprinklers actually went off today, and that would be a bad thing. So I appreciate you guys for putting that on there.
We have a couple more questions here. Do you see residential LED fixtures becoming a better market from an installer standpoint in the next 5 to 10 years?
Well, you're probably asking the wrong guy that question. It's, I'll just say this about residential. There's just not enough there. It's difficult. The thing is, if you go around and count the number of light bulbs you have, or if you guys are from Alabama, they're light bulbs, but you got 100 in your house. Again, the best way I've found to access LED is to buy one every time I go to a home center and bring it home and put it back at my house. I think from a residential standpoint, I really can't speak to where it's going. I can say that LED, I think, is certainly going to impact every facet, every class of trade from a lighting perspective.
There's a lot of very neat things that you can tie in with residential lighting. There's a lot of very unique companies out there that are doing things over Wi-Fi, over Bluetooth, with PAR cans, with screw-in cans. So there's a lot of neat things out there. Some of it is very expensive. To EW's point, maybe pick up one here when you go there, or find instant rebates with your local utility. That may be the best route to go. Or certainly if you're building a new construction home, I would certainly recommend putting in LEDs. But the options are endless out there, and how advanced you want to get with it. So there are a lot of advancements taking place every single day with LED as it relates to residential, and a lot of things tied to security. Not so much maybe on the energy side of things. They're ultimately saving energy, but a lot of things that you can tie in with different security measures, Wi-Fi, Bluetooth, etc.
How long do you consider that must pass? How much time must pass for companies to see the LED technology as an option for saving energy and not as an expensive investment?
Oh, again, I think the time is now. I don't think there's any doubt about it. You have to be very, very careful, and maybe I can answer the question a little bit by providing an example. If you, 4 years ago, an LED product may cost, well, I'll use our LDR. I mean, it was over $200, and it was 51 watts. Now we have products right at the $100 range that are 38, 30 watts, 27 watts. So we're half the energy and half the cost now. So, 3-4 years ago, when it was a 5-year payback, that payback's now 2.5. The economics are there. Now here's the thing that I would point out to you. Yeah, you're worried about the cost. And keep in mind what I said, 85% of your cost of the lighting system is electricity. Do you think that your electricity is going to go down today, tomorrow, the next 10 years? I don't think it is. And so your 85% number is only going to get worse. So we're going to impact that 85% number more than anything, while cost of LED and efficiency continue to go the way that we need it to from a savings.
To tie into that 85% of the actual cost is energy related, depending on what studies you read and what chart you look at, the initial cost is only going to be about 3%. The rest is maintenance. So with LEDs, not only do you have that energy savings, but you also have the maintenance of these lasting 10 to 20 to 30 years for an LED product. So the initial cost is so low when it comes to looking at a project.
And I would add one other point to that. Would you be very careful as you listen to folks that are selling LED? And I've seen again very large companies make the statement that their maintenance savings will equal their energy savings. I've literally seen it on a cut sheet. Let me caution you there. I can tell you within a couple of dollars over the life of a product how much you're going to save on materials. I know what the warranty is. I know how the warranty is on this product, and I know how long this one's going to last. I can tell you what that number is based on today's numbers. I can tell you that. What I can't tell you is how much you pay somebody to put it into your ceiling. That's none of my business. I can tell you also that that labor, that installation piece, to Josh's point, it's about 80 to 90% of the maintenance number. So if you don't fire people, you're not going to save but that 3% on maintenance. So don't let anybody tell you different than that, because it is not true. Anecdotally, yeah, maybe. But here's the thing. Now, yeah, your people that are not now replacing lamps are now out doing something. Let's hope that that something that they're doing is something that contributes to energy savings. That's what I would say about it.
Thanks, EW. With the electronic drivers for both retrofit and new fixtures, what can you tell us about the harmonics and whether LED lighting induces more harmonics on the electrical system or not?
Again, as long as your power factor is up above that 9.9, you're going to look at harmonics that are in the less than 10% THD. If you do something that's different, if you add some resistance to that, it can cause THD to go up. And you have to be careful with that, because that THD does impact your transformers. It will impact your K-bar. So you have to be aware that it could impact other systems that are on the circuit. Typically, lighting is on a separate circuit from everything else, but let's face it, we've got old buildings in the United States. Who knows what else is hooked to that circuit? And it could be your computer that you're messing with. So yes, there are some harmonic issues. With good product that's been tested, it should be below 10%. Now here's the other thing about that. If somebody can't produce that paperwork for you, they can't give it to you, or you can't look it up, you know what? You probably shouldn't buy from those folks. You just shouldn't. And does it happen? Yeah, you bet it happens. I reviewed a project last week, and this kind of stuff just really makes me angry. Because we've got, you know, an Orion, you know, look, hey, I'm an Orion guy. We make really good stuff, okay? But here's the thing. I reviewed a project that is in the class of trade that I work in every single day. And it had 7,000 T-LEDs from China and 237 high bay fixtures from China. Our fixtures are better than that, and they're made here in the United States. So if you don't think the Buy American Act is important, or being made in the USA and using U.S. jobs, good luck with Chinese stuff, because you know what? You can't just send their container back.
Good point.
We've got a couple of technical type questions here. There's a couple people wondering about lumens. They'd like to know if lumens are a measuring tool with LED. If so, why? And then if yes, where's a good reference?
That's a great question, and I thank whoever sent that. Thank you, because that was something that I wanted to cover, because it just came up in a discussion I was having with a customer the other day. Because keep in mind, traditionally, what do we look at when we put a scope of work out there? We look at okay, we've got a 400 watt metal halide fixture over here, and we know LED is twice as good, so we're going to use a 200 watt fixture. There's a different step in there now that's completely foreign to many folks that are not used to using LED. Guys, that 200 watt fixture that you specified to replace the 400 watt metal halide, it could be 20,000 lumens. It could be 11,000 lumens. It could be 27,000 lumens. So here's the next step that we have to take. We can no longer put a scope of work out there that says replace with X number of watts of LED. Doesn't work like that. You're going to get stuff across 100 different barriers. We need to spell out specifically what the lumen package is. So the answer to the question is a lumen package is extremely important, extremely important. The lumens per watt is extremely important. It's not the most important thing, or it's one of the most important things, but it's how we get the light into that space that's still important. So when you look at a product and you look at the lumens per watt and the total lumen package of it, make sure that you design around not just wattage, but also lumen package. The second part of that question was, where do you find out? I think the good thing about that is when a fixture is tested now, whether it's ETL or UL or whoever, it's not just tested for safety, it's tested for performance. So again, if somebody cannot produce the reports, whether it's an L70 or a TM21 or whatever, LM79 report, if they cannot reproduce those reports for you, that product cannot be DLC, it cannot have lighting facts on it. So we've got a third-party measuring company doing the lumen packages for you. You can refer to those. If you get a cut sheet that you don't think is right, then you can look it up. You can literally look it up on DLC's website and see actually what it is. And another point I want to make real quick is the lumen package is also, you also have to understand that a 5,000 Kelvin LED versus a 4,000 Kelvin LED versus a 3,000 Kelvin LED is going to have a different lumen package. The higher you get against traditional lighting fixtures, the higher you get in K temperature with LED, the better it works. It likes higher 5,000 Ks. 5,000 Ks are going to be more efficient from a lumens per watt perspective than 4,000. 5,000 K is still, in my opinion, not a comfortable place to be on inside the building. On the outside of the building, I don't have any problem with it, but inside the building, I like 4,000 K. But it's important that when they quote you lumens per watt, that they quote you what you think you're looking at, whether it's 4,000 or 5,000 K.
And it's important to know because it's the opposite of fluorescent. When we're dealing with
Correct.
T8, T5,
Correct.
the higher you would go, the less efficient it would be.
Correct.
So with
Once
LED, the higher you go, the more efficient
Yeah, when you go from 4,000 to 5,000 K in fluorescent, you lose 50 lumens a lamp. So it's important, it's the complete opposite.
Interesting stuff. We've also got a couple questions here about drivers. Is the life of the fixture dependent on the driver or the LED? And also, what is a typical life expectancy of a driver?
Okay, so let me answer it in a couple of different ways. Typical driver is going to last 5 years. What fails in an LED fixture is the driver first. The LEDs literally might last forever. I mean, if the driver didn't, if it had perfect power, the LEDs may last forever. What you're seeing happen now is the drivers now are moving to a warranty of 7 to 8 to 10 years. The driver manufacturers are pushing that. And they're pushing it because the fixture manufacturers like us made them. So when you see the typical break point in an LED fixture is going to be the driver. If the boards fail, it's usually a wiring issue. It's shook loose in traveling. I hope that answers the question. But typically, at a minimum, you're going to have 5 years. But you're looking at 10-year warranties now in a lot of places.
If you look at it from an hour standpoint, you know, it's very important to look at, okay, how's the fixture manufactured as well? If the fixture's not manufactured well and they don't dissipate the heat well, a driver's going to last less than if it's in a fixture that is dissipating the heat well. Typical driver lifespans can be anywhere from 80,000 to 100,000 hours. And again, that's going to depend on how the fixture is designed itself. So very important when looking at fixture manufacturers and how are they dissipating the heat, how are the fixtures designed.
And again, all that information is tested.
Correct.
By a third party. It's not, it's not EW going out there going, I like that fixture. I think it's 100,000 hours. It's third party tested, and those reports are readily available, and you should ask for them.
Someone's also asking, going off of our lumen talk, also asking about candle power. How does candle power relate with respect to watts?
Okay, two different things, okay? Just so you understand, you have a fixture that has a lumen package. And that lumen package is whatever, 10,000 lumens. Now I've got to take that fixture and put it into a room. That room is going to have inefficiencies built into it. As a lighting guy, my perfect room in my house, this is what I want. I want white tile, white walls, and white ceiling. I'm married. I'm not getting that. So what you have is you've got carpet and you've got different colored paints and shades and things like that all impact the candle power, or what you measure, foot candles. So what we measure in foot candles has to do with the lumen package, but it also has to do with where that lumen package sits, what environment it sits in. So you can't make a judgment based on how many foot candles you're going to have just based on lumen package alone. Because if I take that same fixture, I take a fixture and I put it with a white floor, I'm going to have X number of foot candles. If I then turn and put it onto a concrete floor that's unfinished, I'm going to have a different foot candle level. So the environment that it sits in is just as important as the lumen package.
Take a distribution center, for example. You have a dock area in a distribution center. You could be using a 20,000 lumen fixture in that dock, and you could be getting, depending on spacing and ceiling height, say you're getting 25 foot candles on average. You can take that same exact fixture, put it down an aisle where you maybe have Goodyear tires down that aisle for storage. That black is going to eat up all that light. That 20,000 lumen fixture is going to put a lot less light in that aisle, foot candles delivered to the floor, than it does in the dock area. So you got to take into consideration when you're looking at a project, okay, what's the width of the aisle, what's in the aisles, what's the environment around it, to EW's point, whether it's white, black, reflectance color. So foot candles, delivered light, lumen package of the actual light fixture, both are very important, and working with a company that knows how to take into consideration all the environment is very important.
Yeah, and I think that's a great, I mean, if tires and shingles,
Yes.
they're the worst. So, but I'll say this too, and this is, there's two things that you can understand real quick. Electricity will wait your whole life to get you, right? It will. And number two is, bad audit, bad project. It's not going to come in on time. It's not going to come in at cost. All of those things happen. So spending the time to observe what's there. I'm a big Tom Peters fan. You know, he's a business guru. And he's got this thing called MBWA, Management by Wandering Around. Okay, that's what an audit is management by wandering around. Don't walk by the wall pack that's had a failed photo sensor for the last 2 years and been on outside the building. It's not going to go off until you change the photo sensor. It costs $7. Go do it.
Off of that, does your photo tool account for different environments?
Our photometric
Yeah.
tool, yes, you can use different reflectance values when you're doing the photometric tool. Yes.
A typical value when you assign it is going to be something like 80, 50, 20. I typically go less than that because I want to make sure that you get the foot candles delivered that you want. But the 80, as a for instance, is going to be a white grid ceiling. The 50 is going to be a typical cream-colored room, and the 20 is going to be a floor that's got carpet in it. If you've got things that are different for that, you can adjust either one of any of those things to make a difference.
Okay. Going back to drivers, what has the longest life expectancy, internal or external?
I'm not sure I understand the question.
Yeah.
Internal or external drivers, does one have a longer life expectancy than the other?
Well, they all have to be internal because they have to be inside something. They can't be outside. I don't know.
External to the fixture.
To the fixture, okay.
External to the fixture. So, depending on the actual lumen package, depending again, I'm back on how you design the product. There are certain products that Orion manufactures, some strip fixtures that go up to a very high lumen package. We do an external driver. It's going to last longer being external. If it was inside, the heat would shorten the life of that driver. So, being mounted externally, depending on the application, yes, it would last longer than an internal driver. But if you lower lumen package, design it properly, internal driver is going to last just as long.
Great, thank you. That looks like everything we've got for questions. That was great discussion. And I appreciate everyone submitting your questions, and EW and Josh for your candid responses. So this will conclude our webinar for today. Thank you so much for joining us, and we hope the webinar was beneficial for you. If you do have questions after this time, please feel free to follow up with your Orion representative directly. And also remember that this presentation will be available on demand. We will send you a follow-up email with the link to the video and the documentation, and you can share that appropriately within your organizations. Thanks again for watching, and have a great day.